Hey everyone, Mike here from ArnoldTutoring.com, and in this lesson we're going to talk about some exponential functions. So, as with any function, it always helps to have a good idea as to what the function actually looks like if we were to graph it. Because that gives you an idea of the relationship between x and y if you can't picture it as well just looking at the actual equation. So here we've got one that says y equals 2 to the power of x. Well, just looking at that might be a little bit confusing. Okay, sort of what's going to happen as x gets really big, what's going to happen as x gets small, and how is that going to affect y? So if we have a good idea about what the picture looks like, we can answer those questions a little bit better. So just like any function, if we don't know what this looks like, we can always use a table of values. So I'm going to graph this one first, and then we'll graph this function in green later, and we'll take a look at sort of how they interact. So like I said, we can always use a table of values. And what that means is we're literally just going to manually plug in values for x and see what we get for y. So I'm going to plug in -2, -1, 0, 1, and 2, and that should give us a pretty good idea of the pattern. So when x is -2, we get y is 2 to the power of -2, and we know from our exponent rules that a negative exponent makes the base flip. So we take the reciprocal of the base, so the reciprocal of 2 is 1 over 2, and then we're going to square that. So this is the same as 1 over 2 to the positive 2 equals 1 over 4. So that means I know I have the point where x is -2. We said we will get, if this is -1, -2, -3 down, we said we'll get the point -2, 1/4. Let's go up as well. 1, 2, 3. So -2, 1/4 is somewhere about here. Nice and low. Great. Let's do the same thing for -1. So 2 to the -1. Again, I'm just plugging in -1 for x. This is equal to 1 over 2 to the positive 1. So it's 1/2. Therefore, when x is -1, our y is 1/2. So it's a little bit higher than 1/4. How about when x is 0? Well, we get 2 to the power of 0. We know that anything to the power of 0 equals 1, so that is going to be our y-intercept, because x is 0, y is 1. There you go. Let's go forward. 1, 2, 3. What about when x is 1? 2 to the power of 1, this equals 2. It's just 2 on its own. So we'll take x is 1, y is 2, and lastly, we'll do 2 to the power of 2, which equals 4. Because it's 2 squared, 2 times 2 is 4. So we got to go one more up here, and we get the point 2, 4. So hopefully this shows you the pattern. We can join these. And you can see that the graph is getting really big really fast. And that's a really important characteristic about exponentials. Now hopefully we can see just from the pattern that this is going to start getting closer and closer to 0, but it will never actually get to 0. And if we think about y, this is the graph y equals 2 to the x. It doesn't matter if we put in negative infinity or negative 100 for x. The answer is still going to be positive. It's getting smaller, but it's still going to be positive or above 0. So that makes this x-axis sort of our horizontal asymptote for this function. And we'd often mark that with a dotted line. So again, you can see exponentials get very, very big very fast as they go as x gets positive, and it gets very small, close to 0 when x gets negative. Now let's take a look at what happens here when we add 2 to the x plus 3 and then -1. Again, we could use table of values, but what we can be even sort of smarter about is the transformations. So just like our normal transformations, whether we're moving a quadratic function around or a linear function, when we add 3 to the x value, that moves it to the left 3. So in other words, I can move all of my x value points to the left 3 and keep the y's at the same spot. Now, what does this -1 do? Just like, again, any other function, that takes 1 away from the y value. So what we're going to do is we're going to subtract 3 from x or move left 3, and down 1. Again, you can try this with your own table of values by just inputting values in for x, but you'll see that that actually does work. So all I'm going to do is move each of my x values 3 over. So we'll take this 1/4 point, we'll go 1, 2, 3, and we have a new point there. We'll move this one 1, 2, 3, and it should be there. We'll move our y-intercept. Again, it'll stay at y equals 1. It's going to move 3 to the left, 1, 2, 3. Same thing here, 1, 2, 3. And lastly, we'll move this point, 1, 2, 3. So this is just moving it to the left 3. And then our last step is actually moving it down 1, because that's what our y, that's what that -1 does. So shift everything down 1. This becomes an x-intercept. Notice when we have vertical shifts, it also shifts the horizontal asymptote. So remember how in the original graph we got very, very close to the x-axis, which is y equals 0. Now our horizontal asymptote is y equals -1, because that shift of -1 also shifts that horizontal asymptote. So it's going to look like this, because we've just shifted that down. So this is y equals 2 to the x plus 3 minus 1. And you can see, right, our point, let's take an example. Let's take this point here. Let's test it out. Our x value there is clearly -3. So when x is -3, what do we get for y? We get y equals 2 to, instead of x, we're going to say -3 plus 3 minus 1. So this equals 2 to the -3 plus 3 is 0 minus 1. 2 to the 0 is 1, so it's 1 minus 1 equals 0. And that makes sense because we are on, it kind of holds true because we're on the x-axis, so y is in fact 0. So hopefully you can get a good idea for what exponential functions look like, and know that transformations hold true for exponential functions just like they do for quadratics, just like they do for linear functions and any other types that we've looked at. Hopefully this is helpful. You can always email us with more questions, info@arnoldtutoring.com.